I'm Professor Rad, and this is Precalc video 115, applying vertex form. So in this video, we're going to talk about what the vertex form of a quadratic function looks like, and then we'll apply it to a problem. So we have two main forms that we'll see for quadratics. So the standard form of a quadratic function you've likely seen before is ax squared plus bx plus c. This is, if you think about the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is where all those a, b's, and c's come from, right, from the standard form. So this is useful to help us find the x-intercepts because we have that quadratic formula in terms of these coefficients. But if I want to find information quickly about a quadratic, standard form is not super helpful. Instead, vertex form can be viewed as very helpful. The vertex form is going to tell us the vertex, the axis of symmetry, and the direction that our parabola is going to open, just by looking at the form of the equation. So vertex form is a times x minus h quantity squared plus k. In this situation, all of these constants, a, h, and k, are all real numbers, and a has to be non-zero. A has to be non-zero because if a was 0, we would have a constant function because we wouldn't have this quadratic piece at all. So a is non-zero, but the other variables h or k could be. The vertex is hk, so you can pull that out from here and here. You do want to be very careful because the sign of h is reversed. Because we have this minus here. If this was like positive 3, in the formula, you would see it as minus 3. But k is the correct symbol. So if this was 3, you would see plus 3 up here. The axis of symmetry, sometimes abbreviated AOS, is going to be x equals h. That makes sense because the axis of symmetry of your parabola, so parabolas are symmetric, right? They're the U's. So they're symmetric around that vertical axis that's going to run through our vertex. So it'll have the same value as our x coordinate of our vertex. And then it's going to open upwards if a is positive and downwards if a is negative. Now, all of this also kind of makes sense if you think of this form of the function in terms of transformations on x squared. For example, if I have x squared and I multiply that on the outside by a positive number, that's going to be a vertical stretch. If I multiply it by a negative number, then that could be a stretch, well, or a compress, but also the negative is going to reflect it. So our normal parabola of x squared will be reflected to become a negative x squared. So that's why if that coefficient is positive, we're going to open upwards just like x squared. And if that coefficient is negative, we're going to open downwards because we'll have done that reflection over the x-axis. Also, it kind of makes sense that this is going to be the vertex, the turning point, if you think in terms of transformations as well. So on our normal function x squared, the turning point, the vertex, is the origin, it's 0.00. If I move, I'm going to think in terms of a positive h just for purposes of this right now. So if I had a positive h value, then this would mean shifting to the right to h. And this plus k, because it's on the outside, would mean, if k is positive, shifting up. So this h and this k is going to take that 0.00, move it over h, and up k. So that vertex is now going to be at the point hk. And that's kind of where this is coming from. So let's do an example of looking at a quadratic function in vertex form and using that to help us graph. I've copied down kind of a summary form of our information about our vertex form of our function. For this example, we're going to graph g of x, which is equal to 3 times x minus 2 quantity squared minus 8. And to do this graphing, we're going to use the vertex, the axis of symmetry, and the y-intercept. I've also set up some graphing space here in advance to help us graph when we go to graph. So the first thing we're going to do is we're going to find the vertex. So the vertex is hk, and in our vertex form, we have minus h plus k. So this -2, this is minus h, and this -8, that's going to be k. So for our vertex, h is going to be 2, and k is going to be -8. So we're going to start out by graphing our vertex. Next, it wants us to find and use the axis of symmetry. So the axis of symmetry is going to be x equals, because it's a vertical line, it's going to equal h. So in this case, h was 2, so x is equal to 2. So I'm just going to quickly sketch the axis of symmetry using a dotted line through 2. Now, if you go to graph a line, once you have 2 points, you can connect those points and get your line. For a parabola, we're going to need at least 3 points, and one of them being the vertex, so we know where it's going to turn around. So that's also why, in this case, they've asked us to find the y-intercept, because that's going to be an easy point for us to find. The y-intercept is when x equals 0. So for the y-intercept, we're just going to plug 0 in for x and solve for y. So we'll have 3 times 0 minus 2 squared minus 8. 0 minus 2 is -2, and if I square that, I get 4. 3 times 4 is 12, and 8 from 12 is 4. So our y-intercept is going to be the point 0, 4. So we can go ahead and graph that point. Oh, so we found all the things they told us to find, but I still only have 2 points. I have this y-intercept, and I have the vertex. Now here I've graphed the axis of symmetry, but I haven't used it yet. And that's how I'm going to find my third point. Remember that we're going to be symmetric about the axis of symmetry. That's why it has that name. So if I think about reflecting over that line, I should be able to find a third point by reflecting the y-intercept over that line. So if I reflect it, I'm going to be at the point 4, 4. Now this is a very long and skinny parabola, but quadratics are smooth functions. So remember, your squaring function has a nice rounded bottom to it. It is, and remember, smooth functions don't have sharp corners or points. So we want to be as careful as possible not to make this pointy. We want to keep it as smooth as possible and maintain the parabolic shape. So I'm going to do my best. I can't promise it'll look perfect, but here we go. That's not too bad. So that's our function g of x. Okay, so obviously the vertex form of a parabola is going to be super useful because you can look at the form and then you can pull out all this gorgeous information from that. So if we have a quadratic that's given to us in standard form, kind of makes sense, we want to have a way to convert from standard form into vertex form. So that's what we'll be talking about in the next video. So I hope this introduction to vertex form was helpful, and I hope you have a wonderful day. I'll see you in the next video. Bye for now.